Gravity and Simple Harmonic Motion Review 2. A satellite is in elliptical orbit around a celestial body. Circle all correct answers. At which point or points in the orbit does the satellite have the largest force of gravity? Well, that's going to be when the satellite is closest to the celestial body, so at point C. The largest torque. Well, if the force goes right through the center of mass of the satellite, there's going to be no torque. They're all equal to zero. There's no torque anywhere on that satellite. I just recopied the picture every time so I don't have to keep sliding the paper back and forth. The smallest angular momentum. Well, I think that's going to be the same for everybody. Isn't angular momentum conserved? If there's no torque, angular momentum is conserved. So the angular momentum everywhere is equal, but it's not equal to zero. It's equal to some number, but not equal to zero. How about the largest total energy? There's no friction in space, and so all of them have the same energy, and it's usually not going to be equal to zero. So far, so good. At which point do we have the smallest kinetic energy? Well, that's where the satellite is going to be moving the slowest, and it's going to be moving the slowest at this farthest away point. Letter A there. Number 6, the largest centripetal acceleration. Now, which way is centripetal acceleration? Well, that's going to be directed towards the orbited body, and the force of gravity is directed towards the orbital body. So wherever the force of gravity is the largest on the satellite, that's where the centripetal acceleration is going to be the largest. I think the force of gravity and therefore the centripetal acceleration is going to be largest there at point C. How about the largest tangential acceleration? This one's a little bit dicey, but first of all, at C and at A, there is no tangential acceleration, so we don't have to worry about that. It's between B and D. And if we draw the force of gravity on D, we might draw it as a vector like that. And on B, it's going to look like that. Recall that the force of gravity decreases according to 1 over r squared. So if the distance away is twice as much, as it pretty much looks like here between B and D, B looks like it's about twice as far away from this sun, this star, if you will, compared to D. So that means that the force of gravity is going to be about 1/4 at B compared to D. Now, that force of gravity will provide a tangential component, which will look about like that. And here there will be a tangential component. I will draw the component like that, which to me says that the tangential acceleration will be greatest for D. Because the mass is the same, that tangential component of force is going to be larger than that tangential component of force. I'm going with D on that one. One more. Largest satellite speed? Easy. Whenever the satellite is closest, it's going to have the largest speed.